Okay. So 10.A, most of you have seen water towers in and around small towns. The function of a water tower is to create a desirable municipal water pressure for household and other usage in town. To achieve this purpose, water is stored in large quantities in elevated tanks. You may also have noticed that sometimes the water towers are placed on top of hills or high points in the town. Municipal water pressure may vary from town to town, but it generally falls somewhere between 50 psi to 80 psi. We are interested in developing a table that shows the relationship between the height of water above ground in the water tower and water pressure in the pipeline located in the base of the water tower, shown in figure 10.23. You will calculate the water pressure in psi in the pipe located at the base of the water tower as we vary the height of the water increments of 10 feet. Okay, we will create a table showing our results out to using the high pressure table. What should the water level and now create a file? Okay. The relationship between the height and the water is going to be what? P is equal to rho GH, right? Equal to rho GH. For example, 10.8, where we have a water tower like this, and so the pressure is going to be equal to rho H, where rho is the water density of water, right? Density of water is, what is the density of water? Is given to you as 1.9 slugs per feet cubed. 1.94 slugs per feet cubed. Then we're going to have G, what is G? 32.30. It's 32 feet per second squared. Then we have H, and what are they starting with? Did they give you a start here? Oh, they're just going to calculate that, leave that as it is. Okay. So they want to calculate it in PSI. So we're looking to get pounds per inch squared. PSI. Inch squared, right? This is where we want to be at. Okay, so the feet, this guy's going to cancel. I have foot squared there, right? But I need inch squared, right? So I'm going to have to calculate 1 foot squared is how many inch squared? 1 foot is 12 inches, right? So it's squared, so it's 144. Okay, so now this guy goes away with that. I'm left with that. Okay, so now I have to do pound force here, right? Slugs times the 32 is going to be a pound foot, right? 1 slug is the mass in British unit that will give you a weight of 1 pound force, right? Okay. So basically, if you think you just multiply these together, you should be okay. So you multiply them all together, you get 1.94 times 32.2 divided by 144. So this is pound force, so you get pound force that way, and you're going to have inch squared there. Okay, you can do that. 0.4338 PSI. So this is for, well, and then, well, actually there's the H here, right? Because we haven't specified the H, right? So every 10 foot, they're going to do it, right? Every 10 foot. So if I had 50 feet, if I had 100 feet, what's my PSI? 43.38, right? And if I had 200 feet, it would be 86.76. Right, so they want to go between 50 to 80, right? So that's supposed to go, it's going to be like 100 to 200 feet. Yeah, there you go. The page, Water level. Ooh, okay, something's wrong here. What did we get? 10 foot was 4.3. Okay, that's good. Water level in the tower. Oh, okay, never mind. Okay. Yeah, we're good. So 200 was what? 86.8. That's what we said. 100 was 43.4, just like we said, right? Wants to be between 50 and 80, right? So 50 looks like it's about 120, right? 80 is going to be about 190, so between 120 and 190 feet. It's going to be where we need to be. Okay. Atmospheric pressure. We talked about atmospheric pressure. 118. I'll go to page 319. What atmospheric pressure is 14.7 psi. 760 millimeters in mercury. All right. 118 was 29.92 inches mercury. Okay, so there's your answer there. We were talking about that, how to convert those. Okay. Okay. As you can see, 1 ATM is also 101.3 kilopascals, right? So 1 ATM is equal to 14.7 psi is equal to 101.3 kilopascals. I told you Pascal 1 Pascal is really small, right? So now you can see that we're using kilopascals, right? So this is 101 times 10 to the third pascals. It's a kilo, right? Absolute pressure and gauge pressure. Okay, we talked about that. The gauge pressure does not include the atmospheric pressure, right? Oh, wait a minute, where are we at? Yeah, so if you go to page 320 at 10.16, the bottom there, the absolute pressure is the pressure that you read on the gauge plus the atmospheric pressure. Okay. And I think we will stop here today. Let's do a couple of these. Let's do 10.9. For example, 10.9. Let's do 10.9. Example 10.9, starting with an atmospheric pressure of 101.3 kilopascals or 101,325 pascals. That's the atmospheric pressure, right? Express the magnitude of the pressure in the following units. Oh, they want us to actually derive it? Is that what we're doing here? Okay, so choose to go to row GH, where this was 101.3 kilopascals. And we wanted to do this in what was row? Row was the, okay, so now we're doing in SI units because we're in pascals, right? We're in pascals, so the row is 13,550 kilogram per meter cube. So this is the row of water here. Or is it water or is it, no, this is the one that you looked up, right? Mercury? Mercury, right? This is Mercury, right? Mercury. So row G is 9.81 meters per second squared. And H is what we're trying to find, right? H is what we're trying to find here. Okay, and a Pascal was what? A Newton per meter squared, right? You divide it with Pascal. 1 Pascal was 1 Newton per meter squared, right? So this is going to be what? 101 0.3, or we'll just say 305, 325 was it? 325 Newton per meter squared. Meter squared. Right. So what's a Newton? A Newton is going to be one. So a Newton, 1 Newton is what? 1 kilogram meter second squared, right? Remember, you guys remember this? Yes, no, kinda, maybe. Goes away. This guy goes away, so I'm gonna end up with what? Meter second square kilogram, right? What do I have left here? I have 13550 times 9.81 kilogram meter squared second squared. Second squared is the same, kilograms the same, meter, but I have meter squared here, but that's okay because I'm going to have H is going to be in meters, right? The height is going to be in meters, right? So our units worked out here. Okay, so we're going to try to find H here. H is going to be equal to 101,325. 13550 times 9.81 in meters, right? It's going to be in meters. And if you do that, you get 760 millimeters, or you're going to get what? H is going to be equal to 0.766 meters, which is 766 or 760? What is it? 760. So it's going to be in millimeters. It's going to be 760, right? Because 1 millimeter is no.
Yeah.
10 millimeters is 1 centimeter. Not that way.
Oh,
Close. Because there's one. Basically there's 1,000 millimeters. Right? So that's how you get to 760. Okay. And you can do that in water also, using the density of water. And that's, I'm not going to do that part. Okay. And I think we're good. I'm not going to do the 10.10 and 10.11. You guys should be able to figure that out, and you're going to have to